A month ago, we signed up for this hackathon. The topic of our competition is a design and implementation of a virtual power plant based on blockchain. It is divided into 5 parts. 1. Development status and problems. 2. Virtual power plants, characteristics and control structure. 3. Blockchain-based virtual power plant design and prototype. 4. Scheduling and trading strategies. 5. Deployment and system testing. First, development status and problems. In 1997, Dr. Albrecht first proposed the concept of a virtual power plant. In 2008, Santosh proposed the Bitcoin system to form blockchain technology. In 2013, Ethereum was born. In 2016, the first energy trading system based on Ethereum smart contract appeared in the United States. In 2019, Gavin Wood released the first application chain framework Substrate. The virtual power plant is the latest development, trend, and form of the global energy industry. It is not composed of a real power plant, but is composed of countless small power generation units and large energy storage units behind it. Environmentally, it can significantly improve the efficiency of renewable energy consumption and utilization. Environmentally, the cost of renewable energy power generation has been lower than the cost of traditional energy. In the past 10 years, solar energy has dropped from 6 RMB to 0.5 RMB, a decrease of 19%. The cost of power generation units and energy storage units costs are communicating to fall. In terms of technology, the new Lloyd has the ability of interactive control and active power supply, so that its energy can be converted from one-way to two-way interaction and intercommunication. According to relevant research reports in the United States, the total installed capacity of distributed renewable energy storage, and demand response will reach 66% of the total global installed capacity by 2030, and the current grid and its energy trading market do not have the corresponding design, mechanisms, and solutions. At present, virtual power plants have problems such as lack of fair, credible and low-cost trading platforms, lack of open and transparent information platforms, lack of digital identity authentication, and difficulties in accountability of transaction entities. We believe that the blockchain system can help solve the above problems, because Substrate can ensure fairness, credibility, transparency, and openness on chain, and seamlessly interact with the off-chain system. We chose it as the blockchain application framework. Second, the characteristics and control structure of the virtual power plant. According to the role classification, virtual power plant can be divided into demand response type, supply side type, and mixed asset type. Our design idea this time is the supply side type, which consists of distributed energy storage device leading distributed direct generator sets on the supply side. We give the characteristics and uncertainties of wind power generation. The characteristics and uncertainties of photovoltaic power generation. and the uncertainties of virtual power plant resources. Virtual power plants can be divided into commercial and technical types in terms of function. From the control structure, it can be divided into three modes: centralized control, decentralized control, and completely decentralized control. Considering that in the actual implementation, the virtual power plant undertakes the functions of voltage transformation, amplification, storage, and dispatch, and is handed over to the operation mode of independent operators. Therefore, this design adopts the structural design of the decentralized control mode. Third, the design and the prototype of a virtual power plant based on blockchain. We have joined the overall operation of the system. Green represents energy producers. Red represents energy consumers. Blue PS represents virtual power plants. And blue SG represents centralized grid companies. Producers and virtual power plants conduct energy transactions to obtain money. Consumers conduct energy transactions with virtual power plants to obtain electrical energy. And the scheduling transactions can also be done between VPP and VPP. When the central power grid has too much power, it can sell power to the virtual power plant. When the central power grid is insufficient, it can buy power from the virtual power plant. In this way, the stability of the power grid is improved. Scattered energy weaves into a network for trading, and consumers can also have more choices. Generally speaking, more choices will benefit consumers and help reduce electricity prices. Then we have joined the overall design of the system, which includes the intelligent terminal layer, energy storage scheduling layer, and the chain network application layer. We hope that anyone who abides by the rules can benefit from this platform and truthfully record every transaction through blockchain technology, thereby making the platform more transparent and curbing fraud. Next, we have drawn a diagram of the overall software architecture, which includes the application layer, runtime layer, network layer, device layer, and option worker interaction layer. This project mainly completes the runtime layer and the application layer web deployment, as well as the network layer deployment. Here are three typical module designs. First, the identity management module design is mainly divided into 5 tips. The user's private key logs into the website to obtain the user's address, query identity information, and display different authority pages and buttons according to the identity information. Submit an identity application. If it is a PS application, a deposit is required. The parliamentary approved result will affect the status on the chain. If it is passed, the on-chain identity will be modified. If it is not passed, the on-chain proposed will be rejected. Second, the design of type transaction mode. We are divided into electricity purchase transaction, electricity sale transaction, auguries transaction, deposit transaction, reward and punishment transaction, and dividend transaction. When the user triggers different transaction types on the page, the corresponding transaction function will be coded and comprehensively judged according to the user's identity, transaction type, and additional conditions. After waiting for the dust attack detection and transaction type detection to pass, modify the state on the chain according to the transaction process. Third, the modular design of the Parliament Hall. Parliament requests are divided into 5 categories: membership modification, identity approve, role modification application processing, and treasury dividends. We can add or delete committee members, authorize or cancel PS authorization, role additions, deletions, and changes, appeals for abnormal transactions, and committee dividends and termination. The transaction detection processing mechanism design is divided into 2 paths: outlier analysis and dust detection. In the outlier analysis, we checked whether the total price of each transaction and the price of each transaction meet expectations. In the dust detection, we check whether the price of each transaction and the transaction frequency per W block exceed the extreme value. We have given the weight value of the check item and the definition of transaction health, according to different health and its judgment conditions. Different trading strategies are given. Finally, we give the calculation formula of transaction health. Algorithmic module trading mechanism design. It is mainly divided into 5 parts: AS to purchase transaction data from PS, AS to use knowledge learned to construct an advanced scheduling module, AS to package what some module fields to submit the chain network, and to submit the economic utility data of the module. The AS setting module price, PS judge module validator validity decides whether to purchase. PS purchase module, ChainNet will change the ownership to Alice. If Coral tries to download and deploy without paying, it proposes that it is not authorized to deploy. As shown in the figure, this is our system prototype, which consists of 4 main pages: trading flow, contract management, identity management, and Parliament Hall. First, scheduling and trading strategies. Here we're giving an energy storage scheduling framework and a scheduling strategy. It is usually designed by AS. In the eyes of AS, the system is divided into equipment unit layer, regional coordination layer, and the distribution network leading layer. Then, the virtual power plant is divided into 2 paths: the upper-level electricity price computation module and the low-level electricity computation module. 5. Development and system testing. In the development environment, we used a private test network and simulate 10 cache accounts with some dots by default. Our test environment is configured as follows: 6-core CPU, 16 GB memory, operation system Ubuntu 18.04. The system implementation shows our system operation log and the system operation status. Next, we will demonstrate the main process of the system.